All right, so chapter 9 is all about inequalities, and section 1 is properties of inequalities. So real quick, some review. We've got A less than B, which A is less than B. So when the sign opens to the right, it's less than. And then when the sign opens to the left, it is greater than. So if we're looking at the statement, we have A is greater than B. The signs define what is known as the sense of the inequality. That's kind of some new vocab. Just the direction of the sign, that is the sense of the inequality. And then the two signs of the inequality are called the members of the inequality. All right, a little bit more about the sense of the inequality. If we look at the two equations here, we've got x plus 3 is greater than 2, and then we have x plus 1 is greater than 0. These both have the same sense because they both have the signs that are opening to the left, which is the greater than sign. If you look at the next two, x minus 4 is less than 0, and x is greater than negative 4. Our signs are in the opposite direction, so these are the opposite senses. All right, some more vocab. We have a solution of an inequality. That just consists of all values of the variable that make the inequality a true statement. So everything that we can plug in for x to where maybe the left side is less than the right side, or where the left side is greater than the right side. Conditional inequality, that is where we have an inequality that's true for some values of the variable, but not for all values. And then the absolute inequality is where we have, where it's true for all values of the variable. We're going to go over some of the examples of this next. All right, talking about conditional and absolute inequalities. Let's say we have the inequality x plus 1 is greater than 0. So we would solve this like we would solve if that was an equal sign. So we're going to minus 1 on both sides, minus 1. So you have x is greater than negative 1. This would then be the solution to our inequality. It would be all values x that are greater than negative 1 would fit into this equation originally and be x plus 1 greater than 0. Where these are different from equations, solutions to inequalities are different for equations because this right here is an interval of numbers. So it could be negative 1. It could be, well actually, no, it can't be negative 1. We'll talk about that later. Well, it has to be greater than negative 1. It can't equal negative 1. You guys, I think, should remember these signs. Greater than or equal to, less than or equal to. But so in this case, it can't be negative 1, so we could plug in 0. We could plug in 1, 2, 3, right? All the way up to infinity right there. Any of that would be greater than negative 1. Any values for x. Whereas if you're solving an equal sign, it would just be like x equals negative 1. So this is what we call a conditional inequality because it only works, it only makes it true in this equation for values of x that are greater than negative 1. But if we look at an absolute, let me change colors, an absolute inequality would be something like x squared plus 1 is greater than 0. Because here, no matter what value we plug in for x, we're going to square it, even if it's a negative. Negative 2 squared. Well, negative 2 times negative 2 is positive 4. 4 plus 1 is going to be greater than 0. So anything we plug in for x, and we add 1 to it, we're going to get a value that's greater than 0. So this is a case of an absolute inequality. All right, real quick, greater than or equal to signs. Greater than or equal to, less than or equal to. We can write equalities like x is greater than or equal to negative 5. So it would be all values up to negative 5. So it could be negative 5 in this point. Or we could have x is less than or equal to negative 5. So again, because that line underneath there, it can be negative 5. And everything less than negative 5. So should be a review. Let's say we want to graph inequalities on a number line. So we're just dealing with your basic inequalities here. So for instance, let's say we want to graph x is greater than 2. So we got our number line here. 0, 1, 2, 3, and so forth. because it is a greater than sign, there is no equal to, we're going to do an open circle on 2. Let me change colors. So open circle on 2, and then shade everything that's greater than 2. So this green here, this would be the inequality x is greater than 2. Now, let's say we want to do a graph x is less than or equal to 1. Alright, so here, because of the or equal to, it's going to be a closed circle on 1. So go ahead and make that. Closed circle on 1. And then we're shading everything to the left of that. Alright, one property of inequalities is that the sense or the direction of an inequality is not changed when the same number is added or subtracted from both members or from both sides of the inequality. So for instance, let's say we have the inequality 9 is greater than 6. Let's say we want to add 4 to each member. Or to each side, basically. So if we add 4 here, add 4 here, we now have that 13 is greater than 10. We did not change the signs. Let's say we want to subtract now. Let's see, we've got 9 greater than 6. We want to subtract 12 from each side, each member. Your textbook problems use this terminology. So if we're minusing 12 from both sides, we're not changing our sign in this case. So we've got 9 minus 12, or negative 3, is greater than negative 6. Notice how the inequalities are the same. Like for instance, we added 4 on each side. We just made it so it's the same. It's still a true inequality, except instead of 9 is greater than 6, we have 13 greater than 6. And instead of 9 greater than 6, we have negative 3 greater than negative 6. So we're not really changing the sense of it. We're just kind of adding something to both sides of the equation. It would make more sense when we're dealing with x, which we'll get to that in a moment. All right, our next property is that the sense or the direction of an inequality is not changed if both members or both sides are multiplied or divided by the same positive number. So example 6 goes over this. So let's say we have that 8 is less than 15, and we want to multiply by 2. So multiply both sides by 2. This gives us that 16 is less than 30. So still a true statement, doesn't change the direction, doesn't change the sense. Now, let's say we want to divide. Let's do 8 less than 15 again, and let's divide by 2. So this is going to give us 8 over 2, which is 4. Four is less than 15 over 2. And see, directions didn't change, sense didn't change. Alright, here's where we do change the sign. So the sense or the direction of an inequality is reversed if both members or both sides are multiplied or divided by the same negative number. So example 7 talks about this. Let's say we've got 4 is greater than negative 2. And let's go ahead and multiply both by negative 3. So 4 times negative 3 is negative 12. And negative 2 times negative 3 is positive 6. So to make this a true statement, the sign needs to be flipped. So it's not going to be negative 12 is greater than 6. That doesn't make sense. It's got to be negative 12 is now less than 6. And let's say we're dividing. We're going to do the same thing. Let's say we've got 4 greater than negative 2. And we want to divide by 2. So this is going to, by negative 2. 4 divided by negative 2 is going to give you negative 2. Negative 2 divided by negative 2 is 1. Flip your sign, so you now have negative 2 is less than 1. Alright, next property is a little different. So we have if both members or both sides of an inequality are positive numbers, and n is a positive integer, then the inequality formed by taking the nth power of each member, or the nth root basically of each side, is going to be in the same sense, or the same direction as the given inequality. Symbolically, what this means is that if A is greater than B, then A to the nth is greater than B to the nth, and the nth root of A is going to be greater than the nth root of B. So basically, if you raise each side to the same power, you keep the same direction. If you take the same root, the nth root, the third root, the squared root, whatever, it's going to be the same direction for your inequality. So let's kind of look at an example of this. Let's say we have the inequality 16 greater than 9. So let's say we square both sides. So n is in this case 2. So 16 squared is greater than 9 squared, which gives us 256 greater than 81. Let's look at the kind of opposite. 16 is greater than 9. Take the square root of both. So square root of 16. We want to see, is that greater than the square root of 9? Well, yeah, because we're going to have 4 is greater than 3. Again, these are all just properties of inequalities, mostly stuff that I'm guessing you know, so I'm trying to go through this kind of quickly. Alright, this next example is just kind of writing inequalities with 3 members. So example A, we have 5 is less than 6 and also greater than 2. So start with your 5, less than 6, but we also know that 5 is greater than, so notice how it opens up to the bigger one, so it's greater than 2. You always want to write it with the smaller number first. Now, we can't, for the next one we have 2, we have x greater than negative 1, but we also have, and also, that x is less than or equal to 3. When we write this, you put the x in the middle, put the smaller one on the left, because you want to go from smaller to bigger, so we know that x is greater than negative 1, and then we have that x is less than or equal to 3. Now, for example, C, I want us to consider 2 inequalities. Oh, well, first one. X is less than or equal to negative 4, or x is greater than 2. Let's graph this really quick on a number line. So let's see, I've got 0, 1, 2, and negative 4. So if we're graphing this on a number line, we want a closed circle at negative 4, and it's everything less than that. Open circle at 2, and it's everything, I don't know what I just did. Open circle at 2, and it's everything above that. Now, we have to be careful here, because this is not the same equality as saying, well, x is greater than 2 and this. Now, this inequality here means that x has to be everything greater than 2. So it's got to be everything up here, or can include everything that's up here, and everything that's down here. Well, that's impossible. You can't have a number that's greater than 2, but also less than negative 4. So just be careful where it's or. Sometimes you can't write it like that. You can't combine them together to make it one big one. Alright, example 10 is the last example. It's setting up an inequality application. So we have the design of a rectangular solar panel shows that the length of L is between 80 centimeters and 90 centimeters, and the width W is between 40 centimeters and 80. So we want to find the values of the area that the panel may have. So let's draw a picture real quick. So our length can be, it's between 80, it's going to be greater than 80, and less than 90. And then our width is going to be W greater, well, 40 is less than W, and then W is less than 80. Those are kind of our two bounds there. So area, remember, is length times width. So let's do the smallest area. So the smallest area that we could have, that would be the 40 and the 80. So 80 times 40, which gives us 3,200 centimeters squared. Now the biggest area, so 90 and 80, so 90 times 80, which is going to be 7,200 centimeters squared. So let's write an inequality for this. Here we would have that our area will be between 3,200 centimeters squared and 7,200 centimeters squared.